Hello everyone. Welcome to the series of experiment performance on a triple E subject from the second year mechanical course concerned with the Savitribai Phule Pune University. Today we're going to conduct a last experiment of a triple E subject, that is the blocked rotor test on three-phase induction motor. I am Professor Gajdhane. Welcomes you all. I am working as assistant professor in the Department of Electronics and Telecommunication Engineering from TSSM's Bhurabai Sawant College of Engineering and Research, Nare, Pune. Our aim is to conduct the blocked rotor test on three-phase induction motor. In the previous lecture series or in the previous experiment performance series, we have conducted no load test on the three-phase induction motor. Means there we have to free or there is no any load connected at the shaft of a three-phase induction motor. But here the rotor of the three-phase induction motor is going to be blocked. That's why the name itself indicates that it is a blocked rotor test. So what exactly happens whenever we are blocking the rotor of the three-phase induction motor? We're going to perform an experiment. So what are the learning objectives? To introduce the students to the working principle of a three-phase induction motor, to introduce the students to the equivalent circuit and performance parameters of the three-phase induction motor, to introduce the students to the analogy between the three-phase induction motor and the transformer along with the circuit diagrams of a three-phase induction motor. What are the learning objectives? Means after completion of this experiment, what students will be able to understand? Okay, they will understand the working principle and the equivalent circuit or and performance parameters of the three-phase induction motor. Then they are able to explain the analogy between the three-phase induction motor and the transformer, and they also explain or they are also able to explain the blocked rotor test. Means exactly what happens after blocking the rotor of the three-phase induction motor. So we're going to see in performance of this experiment. This is the circuit diagram of a blocked rotor test. In the previous experiment, there is a block where we can measure the speed, but here we are not measuring the speed over here because the rotor is to be blocked of a three-phase induction motor. Okay, so though there is no any block where we have to measure the speed over here, rather than we have to measure the voltage, current, and wattmeter readings, W1 reading and W2 reading. In the previous no load test, we are giving the rated voltage over there. Okay, but here we have to vary the current up to rated current, that is the 3.8 ampere is the rated current of this three phase induction motor. Okay, so this is the diagram where it is nothing but the delta connected three phase supply. This is the auto transformer where we can from where we can vary the voltage as well as current. Okay, this is the voltmeter. In the voltmeter we can measure the reading of the voltage. This is the ammeter. In that ammeter we can measure the value of the current. This is the wattmeter. This is the symbol actually represents the wattmeter. Wattmeter is nothing but it is used to measure the power required. Okay, so there are two wattmeters we are connected to the induction motor. So students, this is about the circuit connections. Let's see the simulation on a virtual tool. As we have already seen, the virtual tool, that is nothing but the virtual lab. Okay, by going to this address bar or by going to this website, you will get the list of this experiment, that is nothing but the blocked rotor test on a three-phase induction motor. So our aim is to study the blocked rotor test on an induction motor. Next one, by clicking the simulator. Okay, by clicking the simulator you will get this window. Just go to the simulator. Here is the experiment number 4 they are mentioning over there, because this simulator is created by the College of Engineering, Pune. So by just pick up and drop over here, this circuit diagram is appears. So now we will going to conduct an experiment procedure wise. So here is the procedure through which you have to go step by step. So first of all, we have to perform a blocked rotor test. So we are blocking the rotor here. We are blocking the rotor successfully. Then we have to close this TPST switch. Okay, triple pole single throw switch. We have to close this switch. So I'm just closing this switch. The procedure is exactly similar as that of the no load condition, means start the storing data, showing the data. Okay, then we have to select the parameters along which we have to plot a graph, and after that generating graph it will automatically generate a graph over here. So close the TPST switch. I'm just closing the TPST switch, and as the rotor is blocked, so there is no any speed we have to measure across the shaft of the induction motor. So we just have to vary, or we just have to measure the parameters, that is the voltage, current, wattmeter 1 reading, wattmeter 2 reading. Okay, so I'm just increasing the voltage and current. Okay, so the current is nothing but initial current is 0.3 ampere. At that time voltage is 5 volt, and the wattmeter reading is 0.77 watt for the first reading, and second reading is nothing but the 1.50 watt. So these are the readings. Then I have to start storing this data and show this data. So we will get the first reading over here. Next one, I had to increase. Okay, that is nothing but the 10 volt. Then these are the readings. I have to store it here. Then show the data. Then 15. Start storing. Show the data. Then 20, 25, 30, 35, 40, 55, 50, and above 50 there will be a message that motor current is greater than the its limited value. So the motor rated current is nothing but, I already mentioned that it is a 3.8 ampere, so we can't go beyond 3.8 ampere. So this is the last reading of a 50 volts 3.8 ampere. So our table is ready for taking for drawing the graph. So this is the table where we can get the values of voltage, current, wattmeter 1 reading, and wattmeter 2 readings. But here, as we are blocking this rotor of the induction motor, so there is no any speed, so speed will be as a indicated as a 0 over here. So we just have to select voltage versus current graph here. Okay, and generate a graph. So this is nothing but the voltage versus current. So it is going linearly. Okay, it is going linearly. So this is the nature of the graph. Then we have to select the voltage versus input power. So by just clicking the graph, voltage versus input power. Okay, this is the nature of the graph of voltage versus input power. And third one is nothing but the current versus copper loss, means this is the line current and this is the total copper loss. So here is the important, that is nothing but the voltage versus line current. So in this way the graph are to be plotted. Okay students, so these are the natures of a graph whenever we are blocking the rotor of the induction motor. I hope you will enjoy this whole complete series of experiment performance on triple E subject. So thank you for watching actually the whole series, and thank you for watching this video also.